All right, class. The last video was solving two-step equations. We're now going to look at solving multi-step equations. On the notes that you have right here, I've given you 5 steps to solving any equation, whether that be two-step or multi-step equations. On yesterday's notes, you did just steps 4 and 5, okay? We're going to add one more step today to our multi-step equations. So we're going to start today, we're going to start at step 3 and down, okay? So we're just kind of slowly building. Step 4 and 5, those are just two-step. When we start with step 3, these are multi-step equations. So for right now, we're just going to do ones where we have to start at step 3 to 5. On the next video, I will show you how to do steps 1 and 2, which are clearing fractions and decimals and using the distributive property to solve equations. So we will start with combining like terms. Now you've already learned how to combine like terms. You will have to use that skill today with solving multi-step equations. Okay, let's look at example 1. All right, so on example 1, you see that the equation says 2c plus c plus 12 equals 78. So you will notice that there are two terms in here that include a c. All right, so before we can continue like we did yesterday to a two-step equation, we first have to combine those two terms. So if we take 2c plus c, remember there's a 1 right in front of that c. So this is 2c plus 1c. That will give you 3c. And then you write everything else exactly the same. So the only thing I have done is taken the 2c and 1c, and I have joined those two to get 3c. All right, and so now at this point we're exactly to where we were yesterday with two-step equations. So now once we do that, then is when we go ahead and draw our line and we can start getting stuff to one side or the other. All right, so we need to isolate this 3c. This 3c is what needs to be by itself. So you need to ask yourself again, what's in the way of 3c being by itself? And the answer to that is we have a 12, okay, and it's a positive 12. So in order to get rid of this positive 12 on the left side of the equation, we have to do the opposite of addition. This is addition, so we need to do the opposite of that, which is a negative 12. So we're going to subtract 12 from both sides of this equation. Remember, that's how we keep it balanced. So we cancel the 12s, we bring down the 3c, so we get 3c equals, okay, 78 minus 12, that's going to get you 66. And then we divide both sides by 3 to get the c by itself, and we get c equals 22. So c equals 22 in this equation. So really we've only added one more step from what we did yesterday. Okay, now we just need to combine our like terms, and then everything else is exactly like what we did yesterday. All right, looking at letter B, okay, we have 4b plus 16 plus 2b equals 46. So we need to combine our like terms. We have 4b and we have 2b. So if a positive 4b and a positive 2b, we add that, we get 6b. So we get 6b plus 16 equals 46. Okay, so now let's go ahead and draw our line in the equation. We are going to want to get the 6b all by itself, so we need to take care of this positive 16. The opposite of a positive 16 is a negative 16. All right, so we're subtracting 16 from both sides. We cancel out our 16s, bring down our 6b. Try and keep my 6's and b's from looking alike here. And then we have 46 minus 16, that's going to give us 30. Okay, that's going to give us 30. And then we go ahead and get the b by itself, so we're going to divide by 6. Divide by 6. And we divide, if you remember from yesterday, it's because the 6 and the b are being multiplied together, so the opposite of multiplication is divide. Cross out those 6's, and we're going to get b equals 5. All right, let's go ahead and look at example C. Okay, example C, we have 3x minus 4x plus 6 equals negative 2. The ones that are alike are the 3x and the negative 4x. So we need to go ahead and combine those. We have a positive 3 and a negative 4, so that means we have to subtract those numbers. We get 1. We take the sign of the bigger number, which is negative, so we get negative 1x plus 6 equals negative 2. All right, so we've combined our like terms, and now we need to isolate that negative 1x. To isolate that negative 1x, we have to get this 6 out of the way. It's a positive 6, so we're going to do a negative 6 on both sides. Cancel out our 6's. We get negative 1x, because we have to bring down that negative 1x, equals negative 2 plus negative 6. They're both negative, the same sign. So when they're the same sign, you add and keep. So we're going to take 6, 7, 8, and we're going to keep that negative sign. That same sign, add and keep. All right, then we have one more step. The x is being multiplied by a negative 1. Okay, so that means what we need to do is we need to divide by negative 1 on both sides. Okay, that will cross out our negative 1's. So we get x equals, and then we get negative 8 divided by negative 1. Negative divided by negative is positive, so you get x equals 8. Okay, so x equals 8. All right, so I hope these won't be too difficult. Let's go ahead and look at some word problems. Okay, we're going to be talking about a rectangular garden. So Courtney is planning a rectangular garden area in a community garden. Her garden will be next to an existing 12-foot fence. Courtney has a total of 44 feet of fencing to build the other sides of the garden. How long will the garden be if the width is 12 feet? Okay, so what that means is we're going to build a rectangle garden, okay, with fencing. But 12 foot of the fencing is already there. Okay, so we'll say this fence right here, this side right here is already existing. So it's we don't have fence for that. We know we have 44 feet of fencing available to us. We know the width is 12, and the reason the width is 12 is because the existing portion of this is already 12. Okay, so what that means then, if this is 12, we've got a rectangle, so that means the opposite side has to be 12 foot as well. Okay, if we're making a rectangle, we know that the side opposite has to be the same. The opposite sides are the same length. What that leaves us is this length, and I guess I should have made the length a little longer on my drawing. Length is usually the longer side, but this is our unknown right here. What do we do in algebra when we have an unknown? Okay, what we do when we have an unknown is we create a variable for the unknown. Okay, I'll go ahead and use x. We'll use x for length of garden. Okay, so we do know, just like the existing fence and the opposite of that, they have to be the same, so do the lengths. Okay, and if length is x and if one side is x, that means the other side is x. All right, so that's how you set up that drawing in the problem. It's asking how much fence do we have to use. When we're measuring fence all the way around, that's perimeter. So to get the perimeter, the perimeter is going to have to be 44 feet because that's the fencing that we have. So we want 44 feet to come out to be the perimeter. Now to calculate that perimeter, all we do is we add up all the sides. Okay, we don't need to include the existing side. So we're going to take x plus 12. All of this added up together has to be 44. Okay, so now what we're left with is an equation with the same variable, but we need to combine those like terms. So it's just like with the problems we were doing on the other page. So we have an x and an x. When we combine those, we're going to get a 2x plus 12 equals 44. All right, now we need to isolate the 2x. So that means we need to subtract 12 from both sides. That goes away. We end up with 2x equals 44 minus 12. That gives us 32. I'm going to move this up here so I have room. So we have 2x equals 32. So then the last step is the x is being multiplied by 2, so we divide by 2. So then we get x equals 16. Now, in word problems, we can't just leave the answer as 16. We have to actually label this because we're talking feet. So that means the length has to be 16 feet. Okay? And that will meet our requirements of 44 feet of fencing. All right, let's look at the next one. All right, Grant is building a rectangular fence for a playground. One side of the playground is a wall of a building 70 feet wide. He plans to use 340 feet of fencing material. What is the length of the playground if the width is 70? This problem is exactly similar to the other problem. We have an existing side. Okay, I'm going to do this right with the length and the width here. Existing, we have the width. That's 70 feet. Okay, so then the length will be, we'll make the length longer this time. Usually length is longer. Okay, so then if this side is 70, your existing side is 70, so is the other side. We know we have 340 feet of fencing. We don't know what the length is, so again, we're going to say x equals length, okay, of playground. So again, we can label the lengths. We know they have to be the same, so we can label each of those x. All right, so now we can set up our perimeter to equal the 340 feet. We add up the x, 70, and the x. So x plus 70 has to equal 340 feet of fencing. Combine our x's, so we get 2x plus 70 equals 340. Subtract 70 from both sides. All right, so that gives us over here 270. 270 equals 2x. All right, and then we divide both sides by 2. All right, that's going to get us x equals 135 feet. So we know that the lengths are going to be 100. Oops, I'm off the camera view here. So we have x equals 135 feet. And that will give us our required 340 feet of fencing. All right, so please come with questions if you have them tomorrow. And thank you for watching.